All right. Now to start the program off with a real treat, we have Dave Schaefer, the founder and CEO of Cogent Networks. We've been looking for a talk like this for a long time. It's a chance to hear from somebody that built a business from the ground up. The business is the internet, and he's going to tell us why the internet is the only network that matters. So thank you, Dave.
Thanks, Sean, and I'd like to thank everyone for the opportunity to chat and thank NANOG for the opportunity. What I would like to talk about today are maybe some bigger issues that we don't necessarily deal with every day and think about every day. You know, the people in this room have a great responsibility. We are effectively the plumbers for the internet. Billions of people, about 4.4 billion people regularly use the internet globally, but few people could understand what the internet really is, and maybe more importantly, what the value the internet creates for society. And 18 years ago, I had the opportunity to form a company from scratch and literally made the bet that the internet would be the only network that mattered. And in 1999, that was a fairly controversial decision. Everybody believed data was going to overtake voice, but the internet was never viewed as a network that was going to be ready for prime time, that was going to cannibalize every other network and every other service in the telecommunications industry. And the internet has wrought tremendous change. We see the positive change in the way in which we conduct our lives, the way in which our society functions. But those of you who grew up in the telecommunications industry know that the internet has also been responsible for financial distress. You know, Jack put up his slide of all those companies that were combining, and that's just this year. The reality is this is an industry that is under relentless pressure. And our job is to do two things. One, make the internet work better, but two, make sure that the internet is survivable and can continue to deliver that value to society. So Bob Metcalfe, who takes credit for inventing Ethernet, coined a phrase that became known as Metcalfe's Law. The value of the network is equal to the square of the number of devices or people connected to the network. That actually dramatically understates the value of the internet. The value of the internet is really the square of the number of people connected times the percentage of their day that they spend on the internet, then multiplied by the value that time is creating for them. And some of those inputs are easily measured. The value one is difficult to measure. But what the internet has done is resulted in global GDP growth over the past 20 years of about 1% or 100 basis points. With the Great Recession, that really says that virtually all of the economic growth around the world in some way can be traced back to advances on the internet. And what we do with the internet oftentimes appears to have little or no value, but it is those few great ideas that truly create value. And that value comes from literally millions of innovators who now have access to a global footprint, and the barrier to entry to create new business models has fallen dramatically. All of that has occurred because of what we do. As internet service providers or engineers supporting the internet, we have to understand that the internet is actually comprised of a series of fundamental components. What we do is we produce interface routed bit miles connected to other networks. If you're a salesperson selling transit or dedicated internet access, the two ways in which individuals or organizations connect to the internet, if you told your customers you wanted to sell them interface routed bit miles, they would think you're crazy. But we as engineers need to relentlessly drive down those costs in each of those dimensions. So the fundamental business building blocks of Cogent, when we put our business plan together, were 5. 1, that bandwidth is a commodity, and the only way you can win is be the low-cost producer. 2, local networks are a natural monopoly, and as someone who's attempting to overbuild those networks, you need to be very thoughtful about where you deploy capital in overbuilding those networks. 3rd, you needed to get the cost of production down to the very lowest point, and that is the utilization of IP directly over DWDM protected at layer 3. 4th, to interface to the customer and to other networks, you needed to use Ethernet, not because it was necessarily a better technology, but it was ubiquitous, and the cost per bit transferred over an Ethernet port was generally about 3 orders of magnitude less than the cost to move a bit across an SDH or telco interface. And then finally, what engineers often forget is we can build the very best network, but if we don't have customers, it's a science project, not a business, and it's not self-sufficient and self-funding. So you needed to be able to have a value proposition that would lower the cost of revenue acquisition. It is these 5 basic building blocks that allow a company to be an internet service provider and not a telecom company. Now, what's interesting is the internet has some very positive attributes. The first one is it was a network that really had no purpose. That's really the first time in history that happened. Whether you think of a telegraph network, a telephone network, a cable TV network, they all had a specific application in mind. And the internet was different. It was a public network, not a private network, and it was application agnostic. The second key differentiator about the internet is it was originally conceived as an overlay network. It was going to sit on top of infrastructure that already existed. And as we think about those networks, I'm going to break them into 2 constituent areas, and then one has 3 technologies, one has 1. The first is the backbone transport network. And all of the original backbones were built by renting excess capacity from telephone companies, basically wavelengths or SDH services across those backbones. That technology was inefficient and irrelevant for the internet. The internet did not need the 50 milliseconds that a SONET network would deliver. It didn't need the DACs and ATMs to front end the class 4 and class 5 switches that were all involved in the migration of those bits from market to market. So because of deregulation in the mid-90s, there was a proliferation of fiber builds, particularly in the backbone. Prior to that, if you wanted to have a facilities-based network, the way you did it is you went out and for 3 or 4 years secured right-of-ways from road systems, from railways, from pipelines. You dug trenches, you pulled conduit and cable, and you then had a facilities-based network. Because many companies did that before us, we were in the fortunate position to be able to go out and buy dark fiber. People laughed when I went into the room and said, I want to buy a single strand, not even a single pair. I want to buy a national footprint with a single strand of fiber. And what engineers did not fully comprehend was the nascent nature of wave division multiplexing and its ability to continue to advance at an exponential rate. So we heard Jack mention the growth rate of the internet, somewhere around 30% compounded for the past 26 years. That's phenomenal. There's actually no other industry in the history of the world that's had that sustained and that long of a growth rate at that high rate. And that's in fact only the beginning. We still have a long way to grow. That growth is going to come both from new applications being developed specifically for the internet and from applications that exist on legacy networks being ported over to the internet. You know, we had an introduction from Dave Temkin, and his business is basically porting over the viewing of video content from a linear platform to one that is a multi-user, multi-dimensional platform that allows anyone to reach content virtually anywhere in the world when they want it at a lower price point. That is an explosion of choice, and it's a reduction in cost, all made possible because of the internet. That's an example of one application being moved. Voice is an application that has already migrated predominantly to the internet. And then finally, the last bastion of the legacy telecom world has been the private VPN market that is now on the verge of being migrated to yet another over-the-top solution. And these changes are possible because of those advances in wave division multiplexing. So the first wave division systems, 4-channel systems, were deployed by actually Western Electric before it was Lucent in the mid-1980s. Old 4-channel systems with 200 gigahertz spacing and systems that were supporting basically 4 concurrent OC12s. Doesn't sound like much capacity today. The cost to move a bit a mile on existing fiber has fallen at a compounded rate for 32 consecutive years of 80% per year. At the core of the internet, that is what has transformed our industry. And let me put that in perspective. On the internet today, we carry somewhere around 1,800 petabytes of information. The internet is a measurable thing. It's big, it's amorphous, but it is measurable. You can measure how many bits go in, how many bits go out, how they are packaged, and how far they go. It's actually a number that we track on a routine basis. The average bit on the public internet is put into a packet size of just under 900 bits. Ethernet supports 64 up to 1506. 900 is about where the internet works. The average bit on the public internet travels about 2,700 miles, and it can go one of two ways. It can stay within a given service provider's network, or it can traverse multiple ASs. The average bit, that's including those bits that stay on a network, end up traversing approximately 2.4 ASs, and they end up traversing about 8.5 routers from start to finish. 2,700 miles, 1,600 petabytes. But all of that is possible because of that optical transmission core. If we took all of the traffic passed on the public internet today with today's off-the-shelf technology, that's basically 200 gigs per channel. You can buy that equipment today. 400 gig per channel equipment is being early field trialed, but 200 is shipping today. And using both the C and L band, you can support 160 wavelengths at 50 gigahertz spacings. Those are the wavelengths that are optimally served in the EFDA band, basically where erbium-doped fiber amplifiers do their most efficient work. Now, we can widen that band if needed. We can go to higher modulation rates. But the ability to drive down cost is coming from both the elimination of intermediate OEO, optical to electrical to optical conversions. When we first built our network, which has approximately 58,000 miles of intercity terrestrial fiber, we actually needed about 40 OEO conversion points in the network. That's highly inefficient because each time you add an additional wavelength, you have to add the transponder cards in both directions. Today, we have been able to reduce that to only 2 locations globally where we're doing OEO conversion only for signal regeneration. The router can actually perform multiple functions. So rather than having the router be just that, a router, the router can also do the OEO, retime, reshape the signal. It can also do the functions of DAXing and multiplexing that normally had to be front-ended. So it's these reductions in cost and these efficiencies that have given us the first leg of our advances. Even with that 200 gig transport network, and if that network was lit on all 160 wavelengths, we would probably be only utilizing about 15% of that capacity to carry 100% of the world's traffic. But it actually is even more stark than that. There's over 1,000 pairs of fibers between every major city pair in the developed world. 2,000 fibers, we could do all of this on one fiber, not even one pair, if you're running the network in a bidirectional mode. Now, as it turns out, most vendors have elected to go to unidirectional systems, and a 2-fiber solution is better than a single fiber system. But there is no reason why that cost of transport at the backbone won't continue to fall at a comparable rate. We have the ability to use more of the optical spectrum. That EDFA band only utilizes about 8% of the spectrum in the optical waveguide of a piece of fiber. So for all intents and purposes, at the transport layer, we can see costs continue to fall at this 80% compounded rate for the foreseeable future. Now let's go to the router. In the router, you've got a different set of economics. Routing is complicated. It's open source based, but it requires some very specialized processing. The TCAM in a router is somewhat unique, and the market for routing equipment has been more concentrated than for transport equipment. So the cost to route a bit has actually only fallen at a compounded rate of about 40% per year. So transport's falling twice as fast as routing. In addition to that, the interfaces between the transport network and the routing network have become much more streamlined. Virtually all of the networks today utilize pluggable DWDM optics. So when I started Cogent, I remember going to an optical vendor that's no longer in business that was leading the 10 gig revolution. And the general manager of that business unit gave me a 10 gig transponder and put it in my hands and said, this costs $1.3 million. And I looked at him like he was crazy. And I said, you could buy a nice house for that and have a lot of money left over. And he kept arguing the yields were low on the lasers, the technology was complicated. Well, the reality is it was just the production scale was too limited. Today, that level of functionality exists on an SFP pluggable for under $50. So from 1.3 million to $50 is a pretty dramatic price reduction. And it's even more profound than that because it's now a direct pluggable as opposed to needing a piece of transport equipment on the front end. But in building the network, we also needed some things that didn't really exist. We actually wanted to build a fully routed network. Well, the problem was a router cost too much. I know there's a lot of boxes that vendors call routers, but they're really switches masquerading as routers. They don't carry a full table, they won't run BGP, they won't do MPLS, you can't turn NetFlow on them. There's a variety of things those boxes couldn't do. Our network was built as a series of concentric rings for physical diversity. Roughly 710 metro rings, about 31,000 miles of fiber, 198 markets, and at the beginning, we were forced to protect those local networks with a subset of the routing table. We were running OSPF with a local neighborhood. Today, we can run a full IGP, we can do IP fast reroute because every location on the network has a full router. We operate about 6,500 routers on our network. We support about 18,000 active BGP sessions and support just under 6,100 unique ASs connected to our network. Our network allows us to scale at that volume because it is completely routed. All of the switch infrastructure, boxes that had limited capabilities have been removed because that cost of routing has fallen low enough to make it affordable. Now, let's talk about how and where to serve customers. In serving customers, you're an overbuilder if you want your own network. So today, there are 3 existing networks that can all be used for the internet. One is a twisted pair telephone network. It exists ubiquitously in the developed world. It's relatively scarce in the less developed world, but we have roughly 99% teledensity in the OECD or developed countries around the world. That network has some positive attributes. It's a hub and spoke network, meaning everybody has a dedicated connection, and the loop lengths are relatively short, generally about 3,000 feet in North America, about 1,500 feet in Europe. In North America, we have about 223 million pairs of twisted copper, almost exclusively 24 gauge, and it's always terminating at the end point, and then on the other side, it's terminating in 23,000 COs. That infrastructure exists. It would be great to leverage it. The challenge is that the bandwidth on that twisted pair is limited. Even with the most aggressive vectored DSL solutions, ADSL solutions, we can get about 1 megahertz of bandwidth, and because of Shannon's limit, we can effectively only deliver across that probably somewhere between 200 and 300 megabits in the ideal or theoretical case, but in reality, we deliver much less because there's load coils, bridging taps, and that copper plant is 120 years old. So at the end of the day, even though the telephone companies had a bigger footprint, they lost the end user connectivity battle. The second architecture that exists is hybrid fiber coax. And it exists primarily to deliver one-way linear video. It's a coax network that started life as analog. It's generally been upgraded several times, maybe to a 450, a 750, an 860, or a 1 gigahertz digital system. And it actually modulates at a higher level. So rather than being simple binary on-off, it uses QAM 256, 256 discrete energy states of information transfer. But as the number of information states increase, the noise floor increases relative to the transport, and it becomes harder and harder to use DSP technology to pull useful information out. You're also sharing that plant in two ways. One, you're sharing it with linear systems, and secondly, it's a party line. Cable was never designed with unique customers in mind. It was a shared bus. In America, the average cable plant has about 300 users concurrently sharing that bandwidth. That means it works really well, except at peak hours when everybody's turning on unicast channels at the same time, and throughputs drop dramatically. So what carriers have done is bonded more channels together, used better encryption technology such as DOCSIS 3.1, and they have also reduced the number of linear channels, devoting more channels. But ultimately, it's not an efficient network either for delivering the internet. It's an intermediate network. Let's touch on the third network, the mobile phone network. Mobile phone networks were designed to carry analog 64-bit conversations that were voice that typically had a 9.6 kilobit vocoder on them. That's all your phone was equipped with in a 1G system. And the cost to deliver those bits wirely is generally about 2.5 to 3 orders of magnitude, so almost 1,000 times more expensive than fiber. So we're describing a world where the internet sits on all three of these access networks, and all three of these access networks are deficient. What we need is ubiquitous fiber deployment. But the challenge is no one can make money as an overbuilder. Google's tried it, Verizon's tried it, business carriers have tried it, and the reality is less than 20% of the US is fiber connected. Now, there are still builds going on. We saw Jack's map up here from Zayo. They're an aggressive builder. We buy dark fiber from 222 different suppliers around the world. We're a customer of that dark fiber, not a builder of it. We then layer on this metro and long-haul wave division multiplexing, and we deploy that by connecting to the highest traffic locations. That brings us to a target market. We would love to be able to sell services to as large of an addressable market as possible. Every one of you that works for a service provider would like the same. Every one of you that works for an application provider would like to get to as many customers as possible. So having a fiber footprint everywhere would be great. The problem is no one can make money by overbuilding the 2 or 3 networks that exist today. And the reason is your costs are proportional to homes or businesses passed. Your revenue is only proportional to homes or businesses served. And your cost of revenue acquisition is high, making it difficult to get an adequate return on a speculative fiber overbuild. We cream skim the market. At Cogent, we sell services to end users. It's 62% of our revenues, and we only sell to people located in skyscrapers. So what does the average building we connect to look like? It's 41 stories tall, has 51 discrete businesses in it, and it's 12.5 football fields on the roof. Anyone who's driven around the country knows that's not a typical building. And it's the only way we can make money is being that selective about where we build a network. We touch about 10% of all office space in North America, about 870 million square feet out of 8.9 billion square feet of office space. That leaves all the single-tenant buildings, the factories, the hospitals, the schools, and the homes. 130 million homes in North America is unprofitable to serve. That's how we've built a DIA business for end-user customers. The second thing we have done is focused on selling transit. To the people in this room, that's probably how you know Cogent. That tends to be a controversial business. We aggressively try to price our service to give people the very best value. We directly connect in 43 countries to 980 third-party carrier-neutral data centers. So we heard the gentleman from Equinix talk about how they went from 15 to almost 120 data centers. We're in 980 and adding about another 80 or 90 a year around the world. And in those facilities, they are supermarkets for bandwidth. We are selling an undifferentiated, fungible commodity to a sophisticated buyer. Those buyers want quality, but equally, they want price. And to succeed in that business, scale matters. So telecom services has another unique attribute that many other industries don't have. Marginal cost is always below average cost. That says the incremental customer costs you less than your installed base. In economics, there's a concept of a backward bending supply curve. At some point, you hit a threshold where you've maxed out your production capacity and you have to do a step function in cost, raising your costs in the short term to then ride the cost curve down again. That doesn't happen in telecom. And for that reason, scale does matter. And scale comes with price and efficiency. So for 18 years, we have been relentless in driving down the cost to produce interface routed bit miles, taking advantage of every one of those attributes that I've talked about in the market and in technology. Now, for all of the good things the internet has, it actually has some pretty big structural problems as well that people don't dwell on. The first of those is an inherent free rider problem. Listen, we were accused of it for a long time. I'll be honest, I worked very diligently to make sure that was not the case, but many of our opponents came to us and said, Cogent is dumping traffic on us, trying to use our network, get a free ride. We have always, from day one, agreed to offer meds to anyone who will exchange meds with us, to always furthest exit route. We today sell to about 6,100 other service providers around the world. I can tell you that the conversation with every one of those 6,100 started by them saying, we want to be your peer. We want free connectivity and only want cogent routes. We today do peer, and that's a controversial topic. We only have about 30 peers globally. We have an objective set of standards based on network scale, network size, network traffic, and number of ASs connected. We peer with anyone who meets those criteria independent of traffic ratios. Oftentimes, last mile network, heavy networks have said ratios are the way in which we agree who we're going to connect to. No, it is traffic. So level 3 became popular for popularizing the concept of bit mile peering. It's kind of interesting. We proposed that to them nearly a decade before they came out in support of it. Today, that's viewed as a reasonable way to ensure networks carry their own load. So the free rider problem, everybody trying to get a free ride, everybody trying to use their market power, actually becomes anti-competitive and becomes detrimental to the internet ecosystem. May not be that way for the individual getting the benefit, but for the whole ecosystem, it's not building out the infrastructure needed. By the way, the same is true of the opposite side of the relationship, the large content companies. So if you're small and you don't have very valuable content, you fully expect to pay for transit. If you're very large, you say, my content is so important, you as a transit provider should give me a free ride. I'm not going to build a network, I want a ride. And this is often masked by the deployment of CDNs. CDNs are nothing more than distributed hosting companies. If they're a third-party CDN, they are blending the combination of space, power, transport, routing, and interconnection with storage and processing into a finished product. If they are a content provider building their own CDN, they're doing the exact same thing, except they're doing it only for themselves. Also, there is a belief that direct connect is maybe an alternative or better for the internet. And the death of the internet has been predicted probably 8 or 9 times over Cogent's 18-year life. And people said, well, Cogent's going to go out of business because it's a one-trick pony focused on the internet, and the internet's going to be replaced by CDNs. It's going to be replaced by cross connects in a carrier neutral. It's going to be replaced by direct connect. And there is a place for each of those technologies. Data centers that specialize in co-location and cross-connect add a valuable component to the ecosystem. Some of them do that very cost effectively. Others attempt to extract a monopoly profit. And when they do that, oftentimes there's an adjacent center right next door that opens up and supplants them. Direct connects between networks are far more efficient than shared exchanges with intermediate failure points and higher costs associated with them. They're much more efficient than the old direct lease line connectivity model that would have never scaled. But a data center operator has 3 different levers to generate revenue: space, power, and cross connects. And each one of them has their own model on how they kind of play with each of those 3. And we as network operators just want to interconnect. We want to interconnect to one another as networks, and we want to interconnect to our customers, in our case, as a transit provider. And when we do that, We are looking for the most ubiquitous reach and the lowest cost. And what is an interesting phenomena that's really more empirical than necessarily theoretically derived is that bit travel distances have not materially changed in 18 years. And at first blush, that seems counterintuitive with the proliferation of cached content. But it has been supplanted by the globalization of the internet. In 2000, you go back to the early NANOGs, 85% of internet traffic globally originated or terminated in the United States. Today, that's down to the mid-30s, about 35%. And at some point, we're only 5% of the world's population. We're only going to be 5% of the traffic. That's a ways off, but we're going to get there, and that's okay. The internet is a global phenomenon and can add value to everyone. But those companies that seek to use their market power and not participate in the ecosystem, direct connect from content to direct connect to a network operator, if it's cheaper or better, they should do it. If it's done because a network is using its monopolistic power, either on the content side or on the application side, that is detrimental to this ecosystem. So it is the free rider problem and the attempt to use market power to circumvent the engineering forces that are driving down pricing. An interesting study that we commissioned, we were very vocal opponents in the net neutrality debate and in the testimony around Time Warner's proposed acquisition by Comcast. And in that discussion, we found out that the average cost per bit for an end user for the past 20 years has only fallen at 1/8 the rate that it has for transit providers. Technologies are very similar. Yes, there are some differences in the architecture. We've talked about those. But the 8-to-1 differential was really an attempt by those local access monopolies to extract profits, to subsidize their legacy businesses that were being cannibalized by the internet. The internet will be the only network that matters. And the reason is it's better. It's more ubiquitous, it's cheaper, and it is completely flexible. The applications are only limited by the 7.3 billion people in the world and the ideas that they have, most of which will fail, and that's perfectly acceptable. But it goes back to that original concept of value creation, that if a few of those applications catch people's attention, end up having them use the internet more hours a day, consume more bits per hour, and more of them do it, and most importantly, they get more value out of the application. You can't determine that telemedicine is more valuable than watching the next episode of House of Cards. That's an individual decision. People should be free to make whatever decision and run whatever application they want. And just like any part of our society, there can be bad people, there can be people that do evil and bad things with our technology. We are not police. We are not censors. We are not here to limit people's choice. Governments can do that, and we have to adhere to those governmental dictates. We've taken some heat from some of the people in this room for turning off certain sites when a legitimate government issued a legitimate court order to do so, whether it was in the Arab Spring or whether it be in certain terrorist instances. It is not our place to be the policeman. I don't condone, I don't support those misuses of the internet, but it is not our place as engineers. I mean, our tagline kind of says it. Smart people buy dumb pipes. It used to be a joke. Every network wanted to tell you, we're going to move up the value chain. We're going to add value-added services. We're going to do something that other networks can't do. We're going to have better customer care. And the reality is, no company is good at everything. No company creates all of the applications. We need to be good at what we do, which is running networks. And we need to make those networks more reliable. We need to make them more scalable. And most of all, we need to make them cheaper. I often get asked the question, how can you have a transit business when the average price per megabit in your short company's history has gone from a market price of $300 a megabit to a market price of $1 a megabit? And for Cogent, our price during that same time has come from $10 a megabit down to below 10 cents a megabit in some instances. Yet we can make money. And what people don't get is the underlying technologies are improving, and you need to have the standardization of products. Before I came up here, I was talking to someone who has product management responsibility at one of my competitors, and they said, well, we have thousands of products and we can't really make money doing what you do. And I said, that's what competition's all about. That's okay. We don't want to do what you do. We have no core competency in those areas. We have a core competency in delivering those transit bits globally to smaller networks and to content providers. If you look at our transit business, it accounts for 95% of the bit load on the Cogent network, 38% of the revenues. It comes from just about 10,000 customers, 6,000 access networks, about 4,000 content producing companies. Another common misconception is that we're somehow traffic asymmetric. In fact, about 60 to 63% of our traffic stays on our network, never gets exchanged. And we disclose that to both customers. We oftentimes say, well, you're double dipping. You're getting paid on both sides. Well, that's true, but we disclose that. We show you the specific routes. We give you the net flow data. We show you where the traffic's entering, where it's exiting, and to what AS, with what capacity. I don't know how much more transparent we can be. And that's part of why we can drive down pricing. It's that end user business that bothers me more because we can only do it in certain places. We're running out of buildings that fit our end user requirements in terms of size, number of businesses, and aggregate demand. Because we sell no value-added services, that means we need to be efficient at the network layer. Those dumb pipes have to at least pay the bills. So if we look at the total telecom market globally, in the past 20 years, there's been nearly $2 trillion of investor capital, private capital, around the world that's disappeared in telecom. Telecom went from being just under 9% of the S&P 500 to 2.5% of the S&P 500. Many of the companies went out of business. Much of the capital that was deployed is now fallow and was wasted. And that's all because of this level of efficiency that the internet has wrought. And those that work in integrated companies that sell legacy services along with internet products are now on the cusp of facing yet another huge challenge as we see the last bastion of high revenue per bit traffic, MPLS VPNs, starting to be supplanted with VPLS and SD-WAN. Those changes are inevitable. Those products are delivered over a common internet core. And with that, the cost per interface routed bit mile tends to be 15 to 20 times less expensive. Economics may sound boring to engineers, but it's what pays the bills and what allows us to do what we want to do. It's what allows us to create a network and build the scale and deliver the services we want. What I'd like to do in the next 10 minutes or so is maybe shut up from a monologue and try to open it up and see if we have some questions from the floor.
Hi, Dave. Matt Petak from Yahoo or Oath or whatever we are today. Very good talk. Thank you.
Thank you.
One thing that as you were getting to the end there, you were hitting on a topic that Jeff Houston had actually talked about a few nanogs back, which is if you're the person delivering the pipes, you're essentially the sewage company. You are a utility provider. Your ability to extract revenue from that is essentially zero. And if your business model is predicated on that, you're in trouble. How would you respond to that with your business model saying, hey, it's okay to be just the utility, the provider of just the pipe? Do you think Jeff was wrong? Do you think there is value to be extracted from that? Or is it a race towards the bottom?
Sure. So oftentimes I get asked on a price per megabit, this is a race to zero and no one is going to win. Second point is capitalism is the greatest system of economic allocation ever devised. But in a capitalist system, the system ends with no profits. Marginal cost equals marginal revenue. Systems are perfectly resilient and perfectly efficient. Businesses are always trying to create inefficiencies, barriers to entry. And the reality is any utility is a natural monopoly, whether it be water or gas or roads or pipelines or electricity or telephone or internet or sewer. And it was interesting, you picked the one that comes up with a negative connotation of sewer, and you didn't pick the positive one, which is water.
I'll blame Jeff for that because that was his analogy.
You know, running a local network is a monopoly. It's a natural monopoly, and therefore it needs to be regulated as such. It needs to be built with private capital, not public capital. A rate structure needs to be put in place that ensures an adequate rate of return on that capital with an appropriate balance sheet of a combination of debt and equity. Those are all very good things. Now, on the bad side, monopolists always look to do evil. And I know Google's slogan is do no evil, but they do have 90% market share, at least in a market. And I remember meeting John Malone only one time in my life, and he said something that stuck with me. He said, monopolies are great things. The problem is I can't find enough of them. And that's absolutely true. I want a monopoly. Every businessman dreams at night of going to sleep and waking up and having no competitors. Well, guess what? If you build a local network, you shouldn't have a competitor. And the reason is that competitor ends up destroying value because he's building duplicative networks that are going to be underutilized. He's raising the goods for everybody in building that. Now, to protect people, you need structural separation. Network and operating companies need to be separated. Almost the exact opposite of Oath, your current employer, who's looking for a vertically integrated stack. And a structurally separated business was tried in the telephone era and eventually was defeated in Pennsylvania by the Pennsylvania Supreme Court. And ultimately, the internet did what legislation couldn't do. The internet has structurally separated the application from the network and has caused people problems. it's caused them a problem at the exact time that they have other problems. So they have pension obligations, they have debt obligations, dividend obligations, and they're not able to meet all of those obligations. So usually the easiest thing to cut is people. So I don't know what the exact head count at Yahoo is, but I think it's less than it was before. And my guess is we come back to NANOG 74 or 75, it'll be lower again. So I would propose that regulation, at least in North America, is ass backwards. It's tried to create competition at the service level, and it has not addressed the need for private capital at the network level. So you have to wake up, look yourself in the mirror and say, what am I? And a local network is a monopoly, and therefore it needs to be regulated, but it also needs, on the counter, to have an obligation of universal service and quality of service. So there's no shame in delivering roads or electricity or water. There are many aspects of a civilized society that are commodities. We can't live without any of those. In some countries, it's viewed the internet as necessary for life. I'm not sure we're here yet, but I think 10 or 15 years from now, that will be viewed as critical to life as any other utility you get. So the answer is, get used to it. You're a dumb pipe and just live with it. Who's got another one?
Thank you for the answer on that.
Do the next question to the center.
Okay.
Center microphone.
Okay. Hi, my name is Daniel Kahnberg. I'm an internet citizen. Thank you very much for the nice talk. Thank you, above all, for not using PowerPoint or anything and just talking coherently. I really like that. Also, thank you for talking economics to engineers. That's much needed. Anyway, I'd like to address the last mile thing too. Let me just give you an example of where I live. I live in the Netherlands. I live in the smallest village there. It used to be even the smallest incorporated place. Yet I have 2 strands of fiber in my home. Why is this? It's because basically that bit is not run by the government. It's not run by a benevolent company or organization. It's run by some people who are overbuilding, but they have a longer outlook on when they make money. It doesn't have to be the next quarter. It can be 10 years, can be 15 years. It's more like real estate. And I think that's the little bit that we're going to need if we really want the internet out of the overlay networks and get to the point where you can sell maybe me some service. So yes, regulation is one bit. The other is basically getting it into a sector of service, sector of business that has a longer outlook, that looks about building infrastructure and not being a telco who has to turn in a profit in the next quarter. Do you think that's a way of maybe attacking this?
So I am a big believer in private enterprise. There are certain things that are necessarily social goods. Some of those are military defense or certain kinds of health care that we as a society have to take care of everyone. That's part of being human in a civilized world. I'm not sure the internet hits that criteria. I also am actually a bigger believer in people having a longer term view than you are. I'm not as cynical of capitalism being totally quarterly driven. I'm the CEO of a public company. I am measured every quarter. Every day there's a voting machine. My stock goes up, goes down, shareholders get happy, they get angry, and the reality is I think about things over a longer time frame. In the long run, markets are rational. We have a huge actual problem in the world that there's a lack of growth. Because of a lack of growth, Most of the people of our age have a real problem in expecting to retire at the standard of living and having their pensions fulfilled. That problem is not unique to us, it's everywhere in the developed world. And part of it is this short-sighted nature of capital as opposed to a long-term view. There is plenty of capital available looking for good rates of return. And that capital is willing to take a 10, 15, or 20-year view of the world, even 30 and 40-year views. We've seen countries like Italy issue 100-year bonds where investors are not expecting the principal to be paid for 100 years. That's beyond virtually everyone's lifetime, particularly anyone who's buying a bond has got to be at least 10 years old, so very, very few people live to that age. So obviously there's people that take a long-term view, but back to investment. The reason people won't invest and build fiber to your village is one of two reasons. One, there's certain places where the density is just too low to create an economic return. And the only way you can get that type of build in those locations is through cross-subsidization. People in big cities, people pay for people in rural areas. In our industry, people in business pay for residential. They pay higher rates to help subsidize. And those subsidies are actually okay. The other thing is that you have to be convinced there's not going to be an overbuilder. So the problem is you come into the market and you build a new fiber route and you give this great service to someone in a village in the Netherlands, and 20% of the people take the service. 70 or 80% of the people stay on the old services. It's good enough for them. And maybe they're old, maybe they don't want to change, maybe they don't want to watch Netflix, they want to watch, UPC services that are linearly delivered in the Netherlands, the old Ziggo network. And they're very and they said, I'm not switching. So you now all of a sudden have deployed capital to pass everybody, but you only got revenue from 20% of the market. And you've got no protection that another overbuilder is not going to come along. Capital is not going to invest in that environment. So you need to create a regulatory framework that says capital is invested, it's protected, and it's managed to an adequate return. And that return can be high enough that will incent pension funds to flow money in, build it with private capital. Yes, people will get dividends, evil capitalists will make money, but the society will benefit by privately constructed infrastructure. We don't have those regulations today. Maybe they'll exist someday. They actually exist in some other industries. In the electric industry, where there hasn't been this level of technological tumult, it still does exist. I've got a couple more I want to make sure.
So just to know, we have a hard stop in about 9 minutes. So if there's anybody that has a question that isn't at a microphone, please line up so we can manage the queues. And Owen at the stage right is next.
Owen DeLong, Akamai Technologies. You talk about natural monopolies, and I think one of our biggest mistakes that we've made so far is allowing the natural monopoly that exists at layer 1 to be leveraged to a monopoly up through at least layer 3 and sometimes beyond that. And I wonder what your thoughts are on possibly putting a regulatory framework in place that prevents layer 1 monopolies from being leveraged in that way and requires an availability of those layer 1 capabilities to everybody that wants to provide layer 2 and above services.
Yeah, I'm actually going to go down to layer 0, the physical layer, as opposed to even the service layer of transport. I think there should be complete structural separation. So part of the bargain in getting that guaranteed rate of return is that you cannot sell services either yourself or through an affiliated company. You have to make your infrastructure available to all on a unique and on a competitive basis that doesn't advantage one company over another. So I envision a world where at the infrastructure level, we may have a Facebook ISP, and they may go to every customer and say, you know, if you use 10 hours a month of Facebook time, you get your internet service for free. You may get Google saying, well, we're going to one-up them, and you only need to use Google search 5 hours a month, and you get free internet. And it may even go so far as someone will say, you know, if you use us 10 hours a month, we'll pay you to use the network, and we'll pick up the cost. That's what a market is about. And, you know, if Verizon or if Comcast says, we don't want to be in the network business anymore, that's fine, spin that out. You could be another service provider. Maybe you're competing directly with Netflix. You're a curator of content and an aggregator and a markup of content. That's perfectly acceptable. But the whole idea of applications and networks being bound together in a vertically integrated 1 through 3 or even 1 through 7 stack ends up creating this perverse incentive and ultimately hurts the system.
Hi there, my name is Kevin from eBay. I actually have this question more as an individual, however. Sort of curious at the intersection of all of the stuff we've been talking about in the Q&A, from the capitalist side to the stuff you're talking about with, you know, vertical integration, all that stuff. How do you view, from your perspective, the sort of current environment where you see infrastructure providers starting to capitalize the actual data and, you know, looking at what's actually flowing across their pipes, sneaking into it, you know, learning about who's doing what on their network and starting to sell that data in sort of both a capitalistic and regulatory framework?
So there's historically been a concept that a common carrier, which was subject to regulation, would not be able to look into the content that was being carried and was not responsible for the content. That basic concept was what was used in net neutrality when the FCC attempted to support the idea of net neutrality, no blocking, no throttling, no paid prioritization, adequate interconnection. The only way they could do that was classify ISPs as a common carrier, the dirty word Title II. And that then said you were precluded from being in this kind of intercept and intelligence business. Many companies have built great business models by giving away a bunch of free services to people in exchange for the customer paying for something that nobody else would buy from them, their privacy. So when you go on Google, you go on Facebook, these are great services. They're free. Most of the internet is dominated by free services. And the way people pay for those services is with their privacy, with their information. And I think that should be with knowledge, and it should be consensual. I don't think service providers should be in the business of extracting that. We are dumb pipe companies. We should be at the layer 0, layer 1 level and not getting into the application layer. So I know there's an attempt to waive the privacy restrictions on service providers, and they're very subtle about the way they weave that argument together. One is the customer information, my billing information, my residence. That's probably legitimate. You can't deliver the service without having that, and that's information you have to give to the service provider. That's very different than saying, I watched a certain show at a certain time, or I bought a certain set of products, and now I'm going to monetize that information. That's a very different use of personal information. And I am more in favor of this separated model. And I know at Cogent, while we carry a huge percentage of the world's traffic, we are scrupulous of not looking at what's inside of that.
All right, thank you very much.
Thanks. Well, I think we've got, is there any other questions? If not, I know people are probably going to want to take a break here in a little bit, but I want to thank everyone for listening. I know this was maybe a little bit of a different presentation than many of the NANOG presentations, which tend to be very technical and necessary for our industry. And I applaud the work of NANOG. and other engineering conclaves that allows us to move the profession forward. But I thought it would be helpful for me to explain how you can actually build a viable business, because without a business, none of us would be here. There'd be a much smaller room of people that work for research institutions. But almost everybody in this room has a commercial reason for being here, a company that has a profit motive. And while many of those motives individually may not be conducive to the internet, when they're all put together in an ecosystem, they can be. And I really think we need to get away from the mindset that the gentleman who asked the question earlier, that we're selling sewer pipes. We're not. We're selling precious, precious water. If you're in a desert, you need water to survive. You can go a week without food. You can go only about 3 days without water. I would argue in a connected world, there are many people who can't go 3 days without connecting to the internet. And my guess is in the future, that's going to be even much more integrated into our lives. Everything we do, every aspect of our lives has been touched by the efficiencies that the internet has wrought. We should feel proud as people who participate in this industry, not ashamed, not as the rotor-rooter man on the sewer, but rather as someone who brings a vital service that's promoting economic growth and helping lift everybody in the world to a higher standard of living. Thank you all very, very much for the time. Thank you, Sean.